A very good evening, all of you guys. Welcome to Unacademy. Welcome to Kreatryx channel. So, welcome to the course of crash course on our network analysis. That is the Brahmastra batch. So, let's start this session. आप लोग थोड़ा सा कंफर्मेशन दीजिए. Am I audible, visible to you? Yes, everything fine. Thank you. So, let's start the session in that case. Okay. चलो. सो इस कोर्स में आपको क्या मिलेगा, क्या क्या मिलते हैं आप लोगों के इस कोर्स के द्वारा, सारी चीज में देना चाहिए. एंड स्पेशलिटी ऑफ दिस कोर्स, आई वांट टू कंप्लीट इट एज अर्ली एज पॉसिबल इन द क्विकेस्ट पॉसिबल वे. So maybe by next weekend we will be completing. So this week I'll be taking two sessions only, today and tomorrow, but I'll take 2 hours a day. So today I'll start now and I'll take up to 6 o'clock around, and tomorrow also I'll be taking 4 to 6 one more session. Then day after tomorrow, if possible, I'll take. I'm not sure about it. Again, next week we will resume, and the remaining part we will complete in the next week itself. This is the course plan of action. Okay, so by next weekend, this course will be completed with complete syllabus. I think already this initiative is also started by Dande sir, and sir have completed some topics. So उस topics में थोड़ा सा मैं ज़्यादा नहीं explain करेगा. I will quickly move in those particular topics so that it will save your time. And बाकी टॉपिक्स में हम ज्यादा क्वेश्चंस करते हैं. So because it is a crash course, I don't discuss some more theory. I'll try to discuss as much problems as possible. So that is the intention of this particular course. So let's start. Just a moment. Right. So we can start the course. चलो, let's start. सो थोड़ा सा मैं हर दिन को 30 मिनट 40 मिनट तो थ्योरी देता हूँ आप लोगों को. इसके बाद आई विल बी स्टार्टिंग डूइंग मोर नंबर ऑफ प्रॉब्लम्स. अल्टीमेट एम ऑफ दिस कोर्स इज टू फॉर सॉल्विंग मोर एंड मोर नंबर ऑफ प्रॉब्लम्स ओनली. सो प्लीज अंडरस्टैंड दैट. सो लेट्स स्टार्ट. सो आपके लिए अन अकेडमी का फ्यू नया इनिशिएटिव्स. दिस इज द उड़ान बैच गोइंग टू स्टार्ट फ्रॉम टुमारो for you people. So this is going to start with Umesh Dandesar network analysis at 7 p.m. So this is the batch for 2024 aspirants. आप लोगों के लिए this is the batch starting. So if you want to take the plus subscription, start your journey as early as possible. So this is the Bunyad batch. So starting from tomorrow, these are the USPs of this particular batch. आपको comprehensively syllabus तो cover हो पाएगा. रेगुलरली आपको डाउट सॉल्विंग हो जाएंगे. अलग से डाउट सॉल्विंग सेशंस भी होता है. आप कोई भी कोर्स में सब्सक्रिप्शन लेना चाहिए तो आप मेरा कोड यूज कर सकते हैं. ओके, चलो. वेरी गुड इवनिंग ऑल ऑफ यू. सो आपका प्लस एंड आइकॉनिक सब्सक्रिप्शन में आपके प्राइस ड्रॉप जो चल रहा है, आप लोगों को इतना 30 अप टू 30% सेव भी मिलेगा. सो टुमारो तक ये ऑफर तो वैलिड है. आप मेरा अन अकेडमी का सब्सक्रिप्शन, हमारा सब्सक्रिप्शन लेना चाहिए तो यू कैन यूज माय कोड टू गेट 10% डिस्काउंट ऑन द अन अकेडमी सब्सक्रिप्शन. सो ए आईआरएमएस का नोटिफिकेशन तो रिसेंटली रिलीज हो गया. आपको यूपीएससी का जनरल स्टडीज, दैट इज सिविल सर्विस का जनरल स्टडीज और गेट दोनों को मिलके सब्सक्रिप्शन चाहिए तो यू कैन टेक इट यूजिंग दिस. ओके, दिस इज द न्यू बैच going to start from December 18th. So I'll give you further details about this at the end of the class. Before that, let's start the class. आपको भी पता है, अगर हमने नेटवर्क एनालिसिस का टॉपिक ले लिया तो ओके. सो नेटवर्क्स के अंदर क्या क्या चीजें जनरली हमारा सिलेबस क्या है नेटवर्क एनालिसिस के अंदर, लेट अस सी. सो नेटवर्क एनालिसिस के अंदर सिलेबस तो ये है. पहले फर्स्ट फॉरमोस्ट वेरी इंपॉर्टेंट, रेगुलर क्लास में हम बहुत इंपॉर्टेंट से डिस्कस भी करते थ्योरी एक्सेट्रा, दैट इज द बेसिक्स ऑफ द नेटवर्क एनालिसिस. So इस पे we will be discussing the basics like what is current voltage, KCL, KVL, charge का मतलब क्या, energy का मतलब क्या, सभी चीज डिस्कस करते हैं. बट आज ये वाला सेशन पे I will just give you KCL, KVL, node, mesh analysis. Quickly, I'll be completing that, and directly we will be moving for the problems. And I may give some formulas of series connection, parallel connection, what are the different type of elements we have, and different type of sources we have. Then directly we will move for the problems, because this is not a regular course to discuss every single whatever required condition in a elaborately. So let's move. After that, maybe tomorrow or day after tomorrow, then we will discuss theorems, then support. support के लिए मैं एक सेशन डेडिकेट करता हूँ. Then transient and AC. Okay. So इसके लिए 3 to 4 sessions. Okay. And इसके लिए एक session, around 3 sessions I will dedicate for this. So hardly 3, 1, 7 session पे आपका पूरा syllabus तो खत्म हो पाएगा. So no doubt in it. That is what I am planning for you guys. But I will cover almost I'll touch every single topic in the network analysis. So in the basics, what we are going to study first? What we are going to study first in the basics? Let us see. ये तो क्लास में so let us start. So basically हमारा network elements, आप लोग already have studied networks from my comprehensive course. This course will be helpful for you. अगर आप networks आज से शुरू करना जीरो से, this is not the course for you. To be frank, I am giving you the data. आप networks जीरो से शुरू करके you want to learn, then go for my Lakshya batch, or what is that? मेरा टेस्ला बैच पे जाके इंग्लिश स्टूडेंट्स दे कैन गो टू टेस्ला बैच, एंड तेलुगु इंग्लिश हिंदी स्टूडेंट्स दे कैन गो टू द लक्ष्य बैच. इसमें आपको मिलेगा सभी चीज इन डिटेल्ड वे फ्रॉम द जीरो. दिस कोर्स इज फॉर गेट 2023 एस्पिरेंट्स. जो लोग ऑलरेडी नेटवर्क्स प्रिपेयर किया, अभी तो क्या करना चाहिए, लोग थोड़ा सा रिवाइज करना चाहिए, ज्यादा प्रॉब्लम्स प्रैक्टिस करना चाहिए. इन लोगों के लिए ये कोर्स तो बहुत हेल्पफुल करेगा, बट नॉट फॉर द स्टूडेंट्स who are starting for the first time. Okay, so let's start. So basically, any network element can be classified into the types like active, passive, linear, non-linear, unilateral, bilateral, time invariant, time variant, lumped, and distributed. So basic differentiation active and passive में क्या होता है sir? If the element is able to deliver the energy, active, otherwise it is passive. Linear or non-linear का required condition क्या sir? If you plot the VI characteristics, okay, it should be a straight line passing through the horizon for all time. ठीक है. Bilateral और unilateral क्या होता है sir? If the response is the same in both the directions. Suppose मेरा current I1 है, इसमें आपको voltage मिल रहा है V1, so impedance तो Z1. मेरा current तो उल्टा किया -I1. मेरे को सेम वोल्टेज आना चाहिए V1, एंड मेरे को impedance -V1, and the impedance must be -V1 by Z1. So that is a required condition for bilateral. If the response is independent of time, time invariant, otherwise time variant. Elements you are seeing are physically present, lumped, otherwise we call it as a distributive. So these are the things about the classification of elements. Okay, so let me give you a little theory, then we will move for the problems. All these questions we are going to solve. Just a minute. Okay, so this is the first thing. Then let me give you a little more theory, hardly 10-20 minutes में तो थोड़ा सा theory देके then we will directly jump to the problems. So please wait for 5 to 10 minutes. Just it will quickly revise your things also. आपका theory भी revise हो जाएगा. So If you take sources will be classified basically into independent and also dependent. इंडिपेंडेंट का मतलब क्या सर? इंडिपेंडेंट का मतलब क्या? इट इज delivering the energy to the network on its own का मतलब it is not creating the energy, it will be conserving the energy definitely, but it is not taking from some other source and giving the energy. But dependent source, it will also deliver the energy by taking from some other source. So independent में basically we can again classify into voltage source and current source. अगेन इसको हम क्लासिफाई कर सकते एज आइडियल और प्रैक्टिकल, ठीक है. एंड डिपेंडेंट चार तरीका से क्लासिफाई कर सकते हैं. वी कैन क्लासिफाई इनटू फोर डिफरेंट टाइप्स: वोल्टेज कंट्रोल वोल्टेज सोर्स, वोल्टेज कंट्रोल करंट सोर्स, current control voltage source, and current control current source. These are the basics of the different sources we have. So let me explain quickly about all of them. In the independent voltage source, if the source is ideal, it will deliver a constant voltage irrespective of the current flowing through it. इसमें कुछ भी कोई भी करंट जा सकते, but it will give you constant voltage. Practical source में what happens? You will be having internal resistance. So this is the ideal voltage source. This is the practical voltage source which have some internal resistance. So automatically there will be some drop here. With increase in the current, the drop increases. Ideal current source or practical current source. Okay. So these are the basic. I mean very basics ना. इसमें ज़्यादा time spend किया तो it will not become a crash course. इसलिए थोड़ा सा speed जा रहा हूँ. ठीक है मैंने. Then the next one. Series or parallel connection. How do you say the elements are in series, sir? Element series में है तो क्या फर्क होता है? क्या what we call what condition होता है, sir? Current will remain same throughout the network or particular elements you have selected. In parallel, voltage will remain same. In the series, we will go by voltage division principle because series में already current तो same है ना. So what is this voltage division principle is? If you have n number of elements, आपको voltage across a particular impedance m चाहिए. फॉर्मूला तो ये होता है Vm equal to V into Zm by Z1 plus Z2 and so on Z. क्विक रिवीजन, ठीक है. करंट डिवीजन क्या होता है सर? If you have n number of elements in parallel, if you need current in one particular element M, then the formula is given by the total current applied into that particular admittance by total admittance. It can be written as 1 by Z also, that doesn't matter. So this is the basic about the voltage division, current division, series connection, parallel connection. Then if the elements are resistors, regarding Z, resistor का resistance is R, inductance का resistance is J omega L, capacitor का impedance is 1 by J omega C. The basic of the network is KCL, KVL. Okay, if you apply KCL and Ohm's law together, what you get is node analysis. If you apply KVL and Ohm's law together, what you get is mesh analysis. आप लोगों को कम से कम इतना तो पता है मेरे हिसाब से, बिना KCL KVL you cannot understand network analysis at all. If you don't know this also, please don't attend this course. This course is not for you guys. आप basic से KCL KVL everything you want to know, go for my Lakshya batch or go for my Tesla batch. There you can study from the zero level. It is the course for the students who knows at least a little basics for the quick revision. ठीक है, चलो, these are the basics you need. Then we can start the class. I mean, start the session. Lastly, you can also have one more equivalent circuit, star delta. We can start the problems, just a moment. Suppose you have the three elements ZA, ZB, ZC in star connection. You want to convert them into equivalent delta or vice versa. What is the formula I am giving you? If you have a star, you want to convert into delta. What is the value of Z1 is sum of their knowns plus their product by remainder. Sum of their knowns plus their product by remainder. Z2 equal to same formula. ZB plus ZC plus ZB ZC by ZB. Z3 equal to ZA plus ZC. Similarly, you have a delta. You want to convert into star. What is the formula? ZA is product of the knowns by total sum. I'm not explaining anything. I'm directly writing the things because this is very basic part. Okay. So product of the knowns by total sum will give you delta to star connection. So that's all the theory of the starting part of today's class. Now for the entire duration of the remaining part of today's class, around 1 hour, we are continuing the entire part. I'll be giving you the problems only. I'll be discussing the problems only. So let's start with the first question. Definitely, Mayank. Two port, though, I will discuss, don't worry. Right. So let's start with the first question. You people can give a try and give me the answer. So comment your answer. Okay, let me do it. Anybody gave the answer? No answer. Come on. Here, whenever you need equivalent, always keep it in your mind. When you feel the network is having some sort of confusion, so how to solve it easily? In that particular case, आप लोग क्या करना चाहिए? आप लोग nodes को name दे दो, node को name दे दो, ठीक है? Option C, option C. Okay. Listen, this node is having the name C and a T. Okay. I think it will be used to. Now we can do fresh page. That's why what I'm doing. तो नहीं आ रहा है। ठीक है, कोई दिक्कत नहीं, यही पे कर सकते हैं ना। Okay, चलो listen. Here, this node is a C, this node is D, for example. Okay, so already A, B, C, D are present. So here, what is the equivalent between A and B? I need to draw between A, B. Okay, sir. So between A, B, you have an inductance of 1 Henry accepted. Between A and C, what is the inductance you have? Between A and C, I have 1 Henry, sir. Right. Between C and B, I have 1 Henry, sir. Okay. Then you observe one thing very carefully. Node C is shorted to node D. What does it mean? Node C and node D are same. Node C and node D are same. Node C and node D are same. Otherwise, you take the node D, and between D and B, I am solving it is the in the easiest possible way. B and D 2 Henries. Between A and D, I have another 2 Henries. So CD को short करो भाई, ठीक है? And this is the equivalent. So 2 parallel with 1 is 2 by 3 plus another 2 by 3 will give you 4 by 3. So the equivalent will be 4 by 3 parallel with 1. That will give me 7 by 3. 4 by 3 into 2 into 1 by 2 plus 1, 3. 2 by 3, 2 by 3, 4 by 3. 4 by 3 parallel with 1. 3 by 3, 7 by 3 आ रहा है. कुछ गलत किया मैंने. Because this part is in parallel series with this part. आप लोगों को कितना आया? Tell me. 1 minute. 4 by 3 into 1 by 4 by 3 plus 1. तो क्या होता है सर? 4 by 3 by 4 by 7. I'm sorry, मैं calculation गलत. 4 by 7 is the answer. Correct answer. Now wait, आपको एक ट्रिक दे रहा हूँ. जो लोग मेरा क्लासेस ऑलरेडी अटेंड किया उन लोगों को पता है ये ट्रिक, बट those who are new to my classes, for those people, I'll give you one trick for doing the calculations easily. See here, 4 by 3 parallel with 1 na? you can do it by multiplying R1 R2 by R2 R1 plus R2 or Z1 Z2 by Z plus Z1 plus Z2. That is fine. But there is a simplest technique I am giving you. 4 by 3 parallel with. Try to write the numerator as the same. Okay. What is the answer is just add the denominators. Okay. For example, you have 2 parallel with 4 parallel with 6. Okay. You want to find the equivalent. How to do it is, what is the LCM of 2, 4 and 6? It is 6 now. So I can do simply like this. Write it as a 6 by 3 parallel with 6 9 12 12. In this case, 12 by 6, 12 by 3, 12 by 2. Got my answer? Got my point? 2 parallel with 4 parallel with 6 can be written as 12 by 6 is 2, 12 by 3 is 4, 12 by 2 is 6. So the answer is 12 by 6 plus 3 plus 2. That is 12 by 11 as the answer. This is a trick you can apply to calculate the parallel equivalent easily. If you know the LCM, write that. This one has the ratio of LCM to something. Whenever the numerators are same, just add the integers. How this technique help you? Ideally simple. Why? How this shortcut is developed is, what is the meaning of 12 by 6 is, if you have Z parallel with a Z, like that you have n number of Z's in parallel. What is the equivalent for n number of Z's in parallel is given by Z by n. So by using this concept, if you have 2, 4, 6, okay, I can write 2 as 12 sixes in parallel, 4 as 12, 3 12s in parallel, 6 as 2 12s in parallel. Overall is 11 12s in parallel is equivalent to this. Is the indirect reason for giving this method. Okay, so simplest way is take the numerator common, then add the denominator is the simplest way to find the R equivalent. Okay, right? Now it is clear, everybody. So the answer is 4 by 7. Nothing will open here, yeah. Just ये नोड सेम है ना, ये मैंने दोनों को शॉर्ट किया तो 2 4 पैरेलल पे आएगा, 1 2 पैरेलल पे आएगा, बस. राइट, चलो लेट्स गो फॉर द नेक्स्ट क्वेश्चन. ये तो हो गया. नेक्स्ट क्वेश्चन. So please give a try and tell me the R equivalent in this question. Okay, so give a try, tell me the answer, guys. For the circuit shown in the figure, the value of the R equivalent. चार options आपके पास हैं, आपको टाइमर चाहिए तो मैं 30 सेकंड टाइम दे सकते. इससे ज्यादा टाइम तो नहीं चाहिए इस क्वेश्चन. So give a try. So मैं comments देख रहा हूँ. Come on, please comment. come on. No answer. ठीक है चलो. I will explain. Here also go by our method. Give the name A, B, C, D. हो गया क्वेश्चन. केवल आप A B C D लिखो हो गया क्वेश्चन. So what happens here? If you need to find the distance between A and B, okay, one by one we will write. Between A and C, you have 300, right? Between C and B, C और B का बीच में how much distance you have? C and B का बीच में how much distance you have? 500. Then now between A and D, okay, between A and D, you have a resistance of 500, and between B and D, you have a resistance of 300. अरे सर इतना आसान क्वेश्चन है क्या? हाँ बहुत आसान क्वेश्चन है ना. अभी देखो क्या, इट इज 800 पैरेलल विथ 800. सो आंसर तो 800 by 2 400 हो गया क्वेश्चन. सो डोंट मिस एनी कनेक्शन. एक कनेक्शन भी मिस मत करना चाहिए. देन इट इज अ वेरी इजी क्वेश्चन गाइस. यस सर नो. Actually, you see, because you are finding between A and B, आप लोग assume कर लो A current zero. Then it is a very simple question. These two are in series and these two are in series. They are in parallel. So अगर directly देख के आप लोग आंसर दे सकते हैं. नहीं नहीं है तो क्या करना? You should draw step by step. Every single step you need to draw. But give the namings. It is always easy. If you give the namings, it is always easy. Very good. मोहम्मद 400 राइट आंसर. ओके. और कुछ लोग दिया डी. विजय दिया, लक्ष्मी, both of you right answers. So let's move for the next question guys. So consider the network shown in the figure. Again the same model, similar model, you need to find the current. So 40 सेकंड टाइम दे रहा हूँ, थोड़ा सा कम है but we need to do many things here. Give it a try. Time up. No answer. चलो ऑप्शन, मेरे हिसाब से ऑप्शन सी मिलेगा आपको. ओके लेट्स डू इट. ओके लेट्स गिव इट ट्राई. Option C, right answer, Pankaj. So here, what is this current? 5. ये भी 5 है. ये रेजिस्टर जो है ना सीरीज विद द करंट सोर्स, इसको आप नेग्लेक्ट करके भी एनालिसिस कर सकते हैं. सर 3 एलिमेंट्स आर इन पैरेलल. सर मेरे को ये करंट चाहिए सर, क्या करना आप बताओ सर. ठीक है कोई दिक्कत नहीं. Sir, can I apply the current division principle which you have given? Just no, sir. Yes, you can apply happily. You can do by normal node analysis, nothing wrong. That anybody can do. Let's do the question in a different way. In a different way. Suppose if you have some resistor here, then I can apply current division principle. IL equal to total current into that particular admittance by total admittance is the formula. We know it. Just know we have discussed this also. So what to do, sir? देखो भाई, मेरा पास 2i है ना. इसका देखो, ये करंट आई है तो व्हाट इज द ड्रॉप यू विल बी गेटिंग इट. I into 2i। अरे सर पैरेलल पे वोल्टेज तो सेम ही होना चाहिए। सो इफ दिस करंट इज 2i, आई मीन इफ दिस ड्रॉप इज 2i, दिस इज आल्सो 2i होना चाहिए। एक्सेप्टेड और नॉट? एक्सेप्टेड और नॉट? पैरेलल पे वोल्टेज तो सेम सर, दिस इज 2i ओनली। सो 2i by 20 sir, that will be I by 10. This is I by 10. Okay, and you know this is 2i and this is I. This is 5. So you know KCL, entering current should be equal to leaving current. 5 is equal to how much? I plus 2i plus I by 10. So 30i plus I by 10 equal to 5. 50 equal to 31i. I think not option C, option A. Option A. So I equal to 50 by 30. विजय आप लोगों को सी आया? It's correct. Okay. So this is one method. नहीं सर दूसरा मेथड है तो बताओ ना सर, सेम क्वेश्चन करने के लिए और कुछ मेथड है क्या सर? Yes, let's give a try. If there is another method, let me check. Okay. So let me try the same question by a different method to solve this. So listen here. सर पैरेलल पे वोल्टेज सेम है ना सर, ये वोल्टेज ड्रॉप कितना होता है सर? 2i। So what is the resistance offered by this dependent source, sir? This voltage by this current 2i by 2i. Current it will give you 1 ohm. How to know positive or negative? See arrow direction. Arrow positive से negative जा रहा है. So it is, see here, positive resistance. If you have a dependent source, if current is flowing like this, my resistance will be Vx by Ix. If the current is flowing in the reverse direction, then my resistance is minus Vx by Ix. Negative. Okay, it depends on current direction, positive to negative or negative to positive. Here it is positive to negative. How do you know, sir? Because the examiner has given current direction. We know the drop polarity. It is same here also. Okay, fine. What you achieved by this, sir? Yes, very simple. Listen here. Now, if you need IL, total current is 5 into that particular admittance by total admittance 1 by 2 plus, you can just assume this as a resistance of 1 ohm, 1 by 1 plus and 1 by 20. So take the LCM and try it, you get the same answer. Agar there is no calculation mistake, this is 5, this is 10 plus 20 plus 1, 5 by 31 आ रहा है, फिर सेम आंसर आना चाहिए ना, इसमें क्या गलत किया मैंने? I 2i. Okay, we need to calculate IL. Okay, IL is equal to I by 10, same, 5 by 30. Thank you. In any case, because process तो कुछ भी हो सकते हैं, आंसर तो सेम होना चाहिए ना. So this is the right answer, right answer, right answer. ठीक है. Anybody have doubt in this process? You can ask me. Whenever you know the dependent source voltage and current, you can happily replace it with a resistance of its V by I ratio undoubtedly. आप लोगों को इसमें कोई दिक्कत डाउट है तो please ask me. Otherwise, I will move further for the next question. Okay, thank you, thank you. So can we proceed for the next question? Okay, okay, okay. Shall we proceed for the next question? चलो, नॉर्मल नोड एनालिसिस से घर पे होमवर्क करो. So try the homework by normal node analysis. Okay, चलो. Next question for you is ready. You need to find the voltages VAB and VY from the given circuit. Again, आपको टाइमर को ला रहा हूँ मैंने. शुरू कर रहा हूँ. थोड़ा सा मैं 5 सेकंड एक्स्ट्रा टाइम भी ले रहा हूँ. चलो, दे रहा हूँ. 45 सेकंड्स टाइम दिया. ट्राई करो. थैंक यू, थैंक यू. गिव ए ट्राई, गिव ए ट्राई. सो ये तो डेफिनेटली सिंपल सिंपल क्वेश्चन, आसान है. आप लोग तो आसान से कर सकते, कोई दिक्कत ही नहीं मेरे हिसाब से. ऑप्शन सी राइट आंसर. ऑप्शन सी राइट आंसर. मोहम्मद एंड भरत. चलो, लेट मी ट्राई, लेट मी ट्राई. सी हियर. फर्स्टली, these two elements are connected in. ये दोनों एलिमेंट्स कैसा है भाई? ये दोनों एलिमेंट सीरीज में है. सीरीज में है तो हम लोग क्या कर सकते हैं सर? वोल्टेज डिवीजन प्रिंसिपल अप्लाई कर सकते हैं सर. सो वोल्टेज डिवीजन प्रिंसिपल का हिसाब से ये वोल्टेज कितना होता है सर? टोटल वोल्टेज इनटू दैट पर्टिकुलर रेजिस्टेंस बाय टोटल रेजिस्टेंस सर. सो 8 इंटू 6 बाई 2 प्लस 6 ये कितना देते हैं भाई आपको? 6. So the voltage here will be how much? 6 volts. ठीक है सर, मेरे को Vx तो मिला, Vx तो मिला. Okay. Then Vy चाहिए. Vy के लिए here you have a current source of 2Vx. Already आपको Vx पता है. 2Vx का मतलब क्या? 2 6 is 12. So ये करंट 12 एम्पियर. ये 12 ऐसा आ रहा है. ड्रॉप कितना? 12 टू 24. 12 ऐसा आया, ऐसा आया. देन यहीं पे कितना वोल्टेज ड्रॉप है सर? 12. सो ये लूप इक्वेशन अप्लाई किया तो आपका Vy कितना होता है सर? 24 प्लस 12 36. देन आपको Va भी चाहिए बाय द लूप इक्वेशन. KVL नेगेटिव टू पॉजिटिव. Vx से पॉजिटिव टू नेगेटिव माइनस VAB पॉजिटिव टू नेगेटिव माइनस Vy इक्वल टू 0. आपका VAB कितना होता है सर? Vx माइनस Vy. So Vx to 6 minus 36, so minus 30. It is a basic question of just testing your what we call KCL, KVL. So no need to waste much amount of time on this question. So let's move for the next question. चलो, C. बहुत लोग तो C दिया. Perfectly right answer. Vijay, Lakshmi, everybody. So similar model, same आपका KCL, KVL टेस्ट करने वाला क्वेश्चन तो है. So give a try and tell me the answer. So you need to find V2 minus V1. V2 minus V1, the node voltages V2 and V1 का difference पूछ रहा है. ठीक है. So give a try, tell me V2 minus V1. ऑप्शन आंसर दे दो यार, टाइमर देना चाहिए क्या? तो इसके लिए 30। हजार दिया ऑप्शन सी, लेट्स ट्राई। तो बहुत दिन हो गया मैं यूट्यूब पे क्लास लेके। एक्चुअली ये क्लास जो है ना, मैं तो 2 वीक से लेने के लिए ट्राई कर रहा हूँ। एवरी टाइम, लास्ट वीक तो ट्राई किया, मेरे इंटरनेट कनेक्शन पे कुछ दिक्कत हो गया, सो क्लासेस लेने के लिए चांस ही नहीं मिला। सो कल लेने के लिए ट्राई किया, बट आई वाज स्टक इन ट्रॉपिक, आई वाज इन ट्रैवलिंग यस्टरडे, सो नॉट एबल टू, समहाउ टुडे वी आर एबल टू मेक इट। सो चलो गाइस, एक क्वेश्चन के लिए क्या करना। ओके, this model I have done in my regular class also. Firstly, suppose आप लोग तो को भी पता है, suppose some current I is coming here, same current will go here, same current will come here, same current will go here. So ये वाला current और ये वाला current same है। KCL को satisfy करने के लिए current जो entering है ना, हमेशा equal to current leaving at that particular node. So whatever leaving here, same entering here. So to satisfy the KCL, this current must be zero. The same current will come here, it is zero. So because this current is zero and the same current is flowing here, you can say the elements are connected in series. So what is the current flowing in this is 4 by 8. These 3 plus 5. 4 by 8 is 0.5. So zero point 0.5 ampere is going here. 0.5 into 3, 1.5. Okay. So same 0.5 is flowing here. 0.5 into 5, 2.5. ओके सर, कोई दिक्कत ही नहीं है। सो so this is the current flow, fine, so no issue. And here also you have 10, so take the current direction from this 10 by 10, 1 ampere. Okay, so as you know, the same current 1 ampere will come here, come here, come here. Okay, this is also 1 ampere. This is, don't ask me sir ये 1 ये 0 कैसा हो गया, because it is 0, same current will flow. Okay, so fine. Now what is the drop here? Positive, negative, 4 volt. Okay. Now, how to find V1 minus V2, sir? Sir, can I say V2 is 2.5, V1 is 4, 2.5 minus 4 is V1 minus V2? 100% absolutely wrong answer. Because Hamesha you should write the voltage difference with respect to one reference node. We call it as a ground node. Okay. It can be any node. Suppose you take this as your reference. V2 is minus 2.5, no problem. But you should specify V1 also with respect to the same node. Don't specify V1 with respect to this point and V2 with respect to this point. It doesn't make any sense. So in these kind of questions, to make the analysis easy, let us assume the ground like this. Then there will not be any issue. So ये वाला लूप में KVL अप्लाई करो, हो गया क्वेश्चन. So negative to positive V2 and negative to positive plus 2.5, negative to positive plus 6, positive to negative minus 4, positive to negative minus V1 equal to 0. So V2 minus V1 equal to 8.5 minus 4 na, minus 4.5. मैं कुछ कैलकुलेशन गलत किया क्या? ऐसा कुछ नहीं ना. That node always you take it as a positive. He's asking V2 minus V1 only. 2.5. माइनस 4.5 आ रहा है. आप लोग को कितना आया? प्लस 4.5 आया क्या? माइनस ही आ रहा है. कुछ भी कर लो. सो ऑप्शंस गलत है. Whatever you do, you get minus 4.5. If you want the same question in a different way also, I can solve and show you. You take some reference as the ground and try it. Let me show in that way also. Yeah, minus 4.5 perfectly. So let's give a try in a different way. 435. Same question, I am trying in a different method. This is the V1. Okay, chalo. Let's try by different way because I want to show you in any method it is giving you the same answer. ठीक है, मैं इस नोड को ग्राउंड ले रहा हूँ, but for making my analysis easy, so this is 1 ampere current is flowing. 1 ampere. Correct. So 1 force 4 volt, and here how much current is coming? 0.5. Already I have explained how 0.5, so I am not going through the same step again. Now, what is with respect to ground? V2 equal to, it is minus 2.5 minus 6. Minus 2.5 minus 6, that is with respect to the reference. This is the reference. Why this is reference? It is your wish. You take any node as reference and try at home. All will give you same answer. Okay. You take this as reference, anything. The difference will not change. V1, V2 might change, but not the difference. Okay. What is your V1 with respect to the reference? With respect to the reference, it is minus 4. Then what is V2 minus V1? Minus 8.5 minus minus 4 minus 4.5. ठीक है. So कोई भी मेथड आप अप्लाई कर सकते हैं, आपका आंसर हमेशा सेम रहेगा. ओके, चलो let's move for the next question. It is also same model. So don't waste much amount of your time and give your answer. The potential difference across the 3 ohm resistor. I think 5 seconds you need to answer this question. Hardly 5 seconds. Come on. Come on, give me the answer. minus V2. Come on, yeah, give me your answer. 0. Yes. Don't waste your time. इसमें current तो नहीं चलेगा, इसका drop 0. How? Why, sir? Because if you assume some current I1 here, I1 नहीं चलेगा, I1 is coming here, I1 is coming here. So to satisfy the KCL, compulsory, a current to 0 होना चाहिए. Some people will explain in a different way. Sir, there is no return path, so this current to 0 होता है. Any method is fine. That doesn't matter. We always go by KCL, KVL because it is the solid way to answer any question. चलो next question. So the value of the current I, ये वाला current चाहिए आपको, ठीक है? So in this particular network, we need to find the current I. So give a try. So please give a try. Come on. Timer शुरू करता हूँ. So 50 seconds time दिया, आप लोग तो try कर सकते हैं. थोड़ा सा टाइम लगने वाला क्वेश्चन है. I don't think that time is sufficient, but okay. Okay. अरे भाई आपको करंट कहाँ पे चाहिए? इस नोड पे चाहिए सर. ओके सर. लेट्स सॉल्व. Now let me give the node voltages the names V1, V2, and this node voltage don't give any name. If you take this as your reference, with respect to the reference, this is 2 volts now. So this is 2. Yes. Okay. So listen here. So V1 minus V2 by what is your current I? I का फॉर्मूला क्या होता है सर? V1 minus V2 by 1. So आपका काम तो केवल ये है find this क्या बोलते हैं I, that is V1 and V2. So इसके लिए मैं नोड एनालिसिस अप्लाई करता हूँ. बाय नोडल एनालिसिस कहाँ पे? एट द नोड V1. एट द नोड V1. Okay. By the node analysis at the node V1. So write the equation. V1 minus 2 by 1 by 2. V1 minus 2 by 1 by 2. V1 minus V2 by 1. V1 minus 2 by V1 minus 2 by 2 equal to 0. एक equation मिला. The same way, apply the node analysis at the node V2. इसमें V2 minus 2 by 1, V2 by 1 by 2, entering current is minus 1, V2 minus V1 by 1 equal to 0. So आप सॉल्व करना चाहिए इक्वेशन 1 and 2. आपको मिलेगा V1 and V2. After solving the node voltages V1 and V2, you will be getting V1 as 1.76, V2 as 1.19. I is equal to 0.5. कैलकुलेशन पार्ट तो मैं छोड़ दिया, टाइम वेस्ट क्यों करना, आप लोग भी कर सकते हो. ठीक है, राइट. ऑप्शन ए इज द राइट आंसर. So let's move for the next question. Give a try for this question. This is not difficult, not time taking. आप लोग तो आसान से कम समय पे सॉल्व कर सकते. 30 सेकंड और बाकी है. ओके, ऑप्शन -7/6 और 6/7 आती है. एक मिनट, आई चेंज दिया. यस, राइट, लेट्स डू इट. -6/7, right answer. 6/7, 6/7, -6/7 is the right answer. But option A. Okay, let's do this question. So you need to find the voltage V naught. You can do this question by different approaches. मैं तो node analysis पे कर सकते हैं and different ways we can do it. So let me try this. Here, what is this current? ये V naught है भाई, ठीक है. ये तो V naught accepted because V naught by 1 is V naught now. So this current is V naught. This current is 2. Can you tell me what is this current? 2 is coming, V naught is going. So can I say 2 minus V naught? So ये वाला current तो 2 minus V naught होता है. Okay, 2 minus V naught. So अभी आप loop equation apply करो, problem solve हो पाएगा. So ये पूरा loop में KVL apply करो. So here 10 plus V naught. Okay, and here negative to positive plus 4 V naught. Here, what is the drop? 2 into 2. Positive to negative minus 2 2 so much? 4 2 V naught. So 10 plus 5 V naught minus 4 plus 2 V naught equal to 6. So 6 equal to minus 7 V naught. V naught equal to minus 6/7. Okay, so give a try, and I mean, this is how you can solve the question. It is a simple one loop equation से आपको solve हो पाएगा. चलो, let's do the next question. So try this a simple question again. Normal node analysis. You need to find the input R in, the value of R in. Okay. So half an hour more, we will be finishing the class. So tomorrow also I'll take the class 4 to 6 a.m. Sorry, 4 to 6 p.m. Day after tomorrow, I will not be available. I will be going to Hyderabad. So tomorrow we will discuss. If required, day after tomorrow, I will record and give the class for you if you need regularity. Otherwise, next week I will finish this part anyway. So no need to worry about it. Definitely, we do more number of questions in this course, as many as possible, without wasting your time with other things. As many questions as possible, I will be solving it here. Right. So that is about this question. How many of you are able to answer this? No answer. ठीक है चलो कोई दिक्कत नहीं. Let's take this node voltage as V. V minus 12 by 1 mega ohm. V minus 24 by 1 mega ohm plus what is the current flowing 10 microampere equal to 0. So आपको V मिलेगा, ठीक है? So what is that? V plus 12 plus V minus 24 equal to minus 10. So 2V equal to, ये तो 12 होता है ना, minus 10 plus 12 because 12 cancels, V equal to 1. So आपका Rin कितना होता है सर? V by 10 microamperes. That is 1 by 10 mega ohm, 100 kilo ohm, whichever is available in the option. Okay, 100 kilo ohm is the right answer. Next question. Right, चलो. So let's move for the next question. So अभी तक कितना क्वेश्चंस किया एक बार थोड़ा सा रिवाइज करना चाहिए. Okay, so you can see 1 2 3 4 5 6 7 8 9 10 11. Okay, more than 10 questions we have done in the past available time. So let's try to finish little more number of questions, at least every single day. 20 questions is my target. So let's give it a try. So let's move further. Chalo. Next question. So give it a try. So figure shows the current flowing through a capacitor. The charge acquired by the capacitor during the interval 0 to 2 seconds is. Very good, right answer. Option B. So what is the relation between Q and charge? Q equal to integration of IDT. Just find the area. What is the area here? Half into base into height 1. What about the area here? Half into base is how much? 1. Height is how much? Minus 1. Okay. So this is minus 0.5. So the total is 1 minus 0.5. The time is in seconds, charge is in coulombs. Okay, current is also in amperes. Okay, so that is the answer. So don't think that अरे सर इस नोड पे करंट तो जीरो है मैं आंसर जीरो लेता हूँ ठीक है that is not the case. If it is a element is a inductor and they ask you energy, in that case when current is zero, energy at that instant is you can say zero. That is a completely different case, so don't worry about it. Chalo, let's move for the next question. So some conceptual, I mean the very regular basic questions है इसके लिए टाइम भी ज़्यादा नहीं देता हूँ मैंने 10 सेकंड देता हूँ so fast like fast and furious so 10 सेकंड का क्वेश्चन है so answer this question in 10 seconds so hardly you have 5 seconds more. All the passive networks are always symmetrical, different options are given, so in that you need to select one particular option. Time up. Okay, chalo, fastly. All the passive networks are always symmetrical. It need not be. Symmetrical, asymmetrical, we discussed in the two-port networks in general. So passive network can be symmetrical or asymmetrical. It depends. So P को हटा दो भाई. So P वाला options दोनों हटा दिया मैंने. ठीक है. Then Q and R correct or R is correct. हाँ, दोनों केस में Q तो correct है. So don't worry about Q. Don't read Q. R. All the linear networks are always reciprocal. No. Linear, passive, bilateral. This is the condition required for reciprocity. This is a tricky part, but it depends on examiner mood also. Sometimes he may take R is correct also. We cannot say, but normally for reciprocal, this is the condition. Linear should be passive and bilateral. All the active networks are always non-reciprocal. To be frank, this is also wrong. There are some cases where we take active networks, I will show it in the two-port networks, and I can make it to work like active networks. But by default, reciprocity is not applicable for active networks. Exam point of view, you can take Q is the right answer, no option. Chalo, next question also similarly, I am giving you the 10 seconds, give a try. You can select which of the following is correct. You can say, you can comment, PQ sir, QR sir, whatever may be. PQR में कौन सा सही है 20 minutes और है so let's take 20 minutes more the class for 20 minutes more then we can finish it off. Yes, perfectly correct. Kirchhoff laws are valid only for linear. It is 100% wrong. Kirchhoff law is applicable for linear, non-linear, active, passive, unilateral, bilateral. Any network which is lumped. Any network which is lumped, Kirchhoff laws are applicable. So this is wrong answer. Ohm's law is applicable only for lumped. Ohm's law is applicable for lumped and distributed. Lumped may be equal to I Z, distributed sigma equal to j omega. Okay, that is the condition. Then what is that? Ohm's law is valid only at a constant temperature. Perfectly correct. Basics. Okay. So actually node analysis may application point of view where it is applicable, where it is not applicable. If you know, want to know, KCL, KVL are independent of nature of elements. So KCL, KVL are independent of nature of elements. They are applicable for any lumped electric circuit. Ohm's law cannot be applied for sources because they are not linear. Because voltage current relationship must be linear. Ohm's law is applicable only for linear and at a constant temperature. Generally, it is applicable for passive only, but it can be applied for both lumped and distributed. No problem. Chalo, let's do the next question. चलो नेक्स्ट क्वेश्चन। इस क्वेश्चन के थोड़ा सा टाइम दे सकते क्योंकि कैपेसिटर है। चलो भाई, give a try and tell me the answer. I mean, try to find the answer. Equivalent circuits we are solving. Tomorrow I may start to network theorems also. Original heading is equivalent circuits. I don't know, but I may start at the middle. To network theorems will also get started tomorrow. Option B दे रहा है बहुत सारे लोग। लक्ष्मी, दिया बी, कुमार, आजार, तेजा, Mohammed and Bharat, Vishwatis, everybody right answer. Everybody, it's the right answer option B. ठीक है भाई, क्या करना? So कैपेसिटर्स पैरेलल पे है तो सर मैं क्या करता हूँ, ये दोनों को ऐड करना चाहिए। C/2 plus C/2 will give me C. So C/2 plus C/2 will give me C, sir. Now C and C are in series, sir. C and C are in series. C और C series में है तो आपका equivalent कितना होता है? C/2. फिर again C/2 and C/2 कितना देती है सर? C, because capacitors parallel में we will be adding it series C1 C2 by C1 plus C2. ठीक है? So now what happens? This is a C, C and C. Three capacitors are in series. What is the equivalent? C by capacitor का formula हमेशा it will be reverse. Okay? चलो next question. Right. Ronak, Nageshwar, everybody right answer. Next question. इसमें केवल कैलकुलेशन इससे अलावा कुछ नहीं है। ठीक है। R equivalent is 1 parallel with 2, parallel with 3, and so on parallel with 10. Okay. You can write 10 by 1 plus 10 by 2. Like this, not possible because LCM of all of them. Okay, leave it. So you can write conductance equivalent, G equivalent. G equivalent is sum of individual G's, that is 1 plus 1 by 2 plus 1 by 3 and so on 1 by 10. Okay? What is the conductance? It is sum of all. So it will give you 2.9. Calculation you do it at home. Calculator apply karo yaar, 1 inverse to 10 inverse add karo. Then what is your R equivalent? 1 by 2.9. So that will give you 0.3. Right? Option B. Right. Chalo, next question. Next question. Next question. So find the current I in the circuit shown in the figure, sir. सर इसमें करंट निकालो. ठीक है. It's not a balanced bridge. 1 by 2 not equal to 3 by 4. So don't think the current is 0. So find any other answer. Any answer? Any answer here? 2.1? No. 2.0 2. R equivalent निकल रहा है आप लोग. R equivalent नहीं. Current in this match चाहिए. You need to find this current. Last 15 minutes of your class. Okay, let me do it here. Firstly, what is the R equivalent? R equivalent is 1 parallel with 3 plus 2 parallel with 4, sir. So 3 by 4 plus 4 by 3. Okay. Now, it will give you 9, 16 by 12. 9 plus 16, 25 by 12. 2.01 approximate. Actually 2.01 भी नहीं, 2.08 मेरे हिसाब से. Right. So here, if you find the input current I in, what is the input current, sir? I in is equal to 10 by 2.08. Let me do this calculation first. KLC by, ठीक है, 25 by 12, 2.0833. Okay, 10 upon 2.0833. Okay, it is approximately 4.8 current. Now listen carefully. Let me try it in the next page so that it is very convenient for us. You need to find this current. See, very simple. This current is 4.8, guys. These two elements are in parallel. We can apply current division principle. By using current division principle, what is this current and what is this current? 4.8 into 3 by 1 plus 3. Or you can say if you divide 4.8 into 4 parts, 3 parts, that is 3.6 will go here, 1.2 will go here. And also this current entering should be leaving also. A 4.8 है तो it is in the ratio of 1 is to 2. So current will be divided in the ratio of 2 is to 4. So if you make it into 3 parts, here you get 3.2 and 1.6. Because ultimately the drop here is 6.4, 6.4. 3.6, 1.2 into 3, 3.6. Current division principle मैंने apply करके ये current. Don't apply for the whole network. Firstly, these two are in parallel. Entering is 4.8. So by current division principle, divide the current. Similarly, leaving is this much. Again, these two are in parallel. Find the currents. Okay, or by using the ratios R1 by R2 equal to I2 by I1, any method you can apply your convenience. So I divided in the ratio of 3 and 1. I got 3.6 and 1.1. Now just apply KCL. What is the KCL? At that particular node, 3.6 is entering, 3.2 is leaving, I is also leaving. मेरा I कितना होता है सर? 0.4. बस. Here also you can apply 1.2, 1.6 different for 0.4. Here you can commit a mistake like this. आप लोग ये mistake तो कर सकते हैं यार. ये mistake क्या? Some people will do like this. Okay, in that case, what happens? This will be 4.8 and this will also be 4.8 only. Okay, this is wrong answer. Okay, so don't take this current. ये current अलग है, ये current अलग है. Okay, because you can short them and take this part separate. Nothing wrong in that. That will give you this current, not this. ठीक है? चलो, let's move further. 0.4 very good. How many लोग? 3 लोग दिया. तेजा, भरत and मोहम्मद. Very good, right answers. ये क्वेश्चन तो आसान है. आप सोर्स ट्रांसफॉर्मेशन अप्लाई किया तो केवल सिंगल स्टेप में आएगा. So I am directly doing it. Don't waste your time. So current I is 80 by 32, 42. Okay, a single step questions. 30 सेकंड भी नहीं चाहिए इस क्वेश्चन सॉल्व करने के लिए. सोर्स ट्रांसफॉर्मेशन अप्लाई किया तो एक स्टेप में आंसर मिलेगा. ठीक है. नाउ आई आस्क यू वन क्वेश्चन. टेलीग्राम चैनल चाहिए मेरा देवेश. जस्ट you can take that. Somebody already typed there, you can see. I thought of giving it. Okay, chalo. Listen here carefully. I will ask you one question, beautiful question. Some people might know it if you have already attended my class, otherwise you don't know, definitely. I want to find this current. Can you solve this question by source transformation? Can you find I1 by using source transformation? Yes or no? Because if I apply source transformation, this branch is getting disturbed and moving like this, and current here is changed to how much? 2 ampere. But originally it is not 2, because it is a 10. This is 2, already we got it. This will be 8. Okay. But can you try or solve the same? Suppose if examiner asks you to find I1, is it possible to apply source transformation and solve it? Yes or no? Please respond. Please respond. सोर्स ट्रांसफॉर्मेशन अप्लाई करके इसको सॉल्व कर सकते नहीं कर सकते. इफ यू नीड ए करंट इन द 4 ohm रेसिस्टर इज माय क्वेश्चन. अरे रेस्पॉन्स दे दो यार. ओके लिसन. नहीं नहीं, दोनों अप्लाई करना है यार. 5 एम्पियर किया तो सभी लोग तो कर सकते हैं यार. चलो लिसन. I will show you how to do this kind of questions with source transformation. Okay. So right. This is the current I. This is the current 10. And this is the current 10 minus I. If a branch is getting disturbed by the source transformation, then that branch current will also disturb. ठीक है कोई दिक्कत नहीं. So if I apply source transformation here, let's try green color both. Then this will become 40 in series with 4. This will become 8 and 8 5 is 40. Now बीच में connected 28. Only this current remains same. बाकी तो disturb हो गया, so बाकी का values need not be the same because I applied source transformation. ये दोनों branch तो disturb हो गया भाई, कोई दिक्कत नहीं है. इसमें I निकालो. I कितना 40 minus 40 minus तो plus by 4 plus 28 plus 8. That will give me 2. I got this 2. देन हाउ टू फाइंड दिस करंट. सर यहीं पे ये भी 2 है सर. नहीं सर मेरे को ये करंट चाहिए 4 ओम पे. 4 ओम पे. earlier I already know answer is 8, but if I take this current 2 आ रहा है ना, so current in the 4 ohm if we need, okay, current in 4 ohm. Don't try here, but you can answer, you can get the answer from here. How sir? Use the relation. Use the relation. What is that? The current in the 4 ohm resistor, okay, that is I1 na. I1 is equal to 10 minus I. I got I now already, 10 minus 2. This is how you can get the answer. Means if you need, if any branch is getting disturbed by the source transformation, still you need the response in that particular branch. आप लोग तो इसको solve कर सकते हैं by finding, by apply source transformation, but use the relation before the source transformation to find the response. Understand this logic? In that case, you don't never feel any difficult. Chalo. Right? Now it is clear? Okay, chalo, next question. Last 5 minutes of your class. Right. Try this question. This is the last question for today's class. आज के लिए ये आखिरी क्वेश्चन है भाई आपके लिए. चलो. Give it a try. No answer. चलो यार क्या. No right answer. Nobody gave any answer. Last question बोला ना मैंने. Thank you. Sai, Teja. 12 amperes ऑप्शन सी बोल रहे हैं आप लोग. ठीक है, let us see what will be the answer. So we can try the question by different approaches. So let me solve by the first simplest possible approach. Here, uh, when Vs equal to 3, in the above circuit, when Vs equal to 3, you got the current I is equal to 4 amperes. Okay. Okay. So let's solve. Shall I draw it in the next page? Right. 333, I guess is better. Last question, okay. When Vs equal to 3, the current I is equal to 4 amperes. So this node voltage will be 12. This node voltage will be 12. Okay. So what is this node voltage? आपको 12 आया ना? So here 12 minus 3 by 3. 4, 12, 9 by 3 is 3 na? So this is 3 ampere, this is 4 ampere. What is this current by KCL? KCL को satisfy करने के लिए entering current should be equal to leaving current. So I got IS equal to 7. Now you keep the same thing, same circuit. 3, 3, 3, and this is 9. IS is 7. Examiner को क्या चाहिए भाई? I चाहिए. Happily find it. What is the I? Okay. So find this node voltage first. V by 3. 7 is entering. V minus 9 by 3 equal to 0. Take the LCM. V minus 21 plus V minus 9 equal to 0. 2V equal to 13. V equal to 15. ठीक है, then I equal to V by 3. 15 by 3. How much? 5 ampere is the answer. 12 क्यों दिया सभी लोग? 5 आएगा when Vs equal to 9. So this is one method. There is another way to do it, or apply superposition. When only one source is applied at a time, what is the current? Here I1 equal to 0.5. Okay, got my point. 3 by 6. Next, when you apply here IS, this is 3, this is 3. ये भी 3 है ना, voltage source को short circuit कर लो. Now here you get the current of IS by 2, because current division principle, whatever entering equal impedance में equally divided. But to satisfy your 4 ampere condition, this must be 4 minus 0.5, that is 3.5. Okay, fine. Don't calculate IS. ये नहीं चाहिए मेरे को. अभी देखो, this is your I2. Total I equal to I1 plus I2 superposition. Okay, कोई दिक्कत नहीं. Okay. Or you don't find anything also, no problem. Total I1 plus I2 is this one. No need to draw this figure also. Now what happens? The same IS, the same 3, same 3, same 3, but input is made equal to 9. So input is 3 times 3, na? So here earlier I1 plus I2, na? Now it will be 3 I1 plus I2, because this input is multiplied by 3 times, output also multiplied by 3 times. 3 times 0.5. I2 remains the same because the second source is not disturbed. So what is the second source value? 3.5 answer. Any method will give you same answer. In fact, you can skip this step also. There is no need of this step. You understand I1 equal to 0.5, automatically I is equal to 4, then I2 equal to 3.5 is what you should understand here without drawing this figure also. There is no need of this figure. Directly you can see. So this is by superposition. This is by using the information given by examiner. कोई भी method apply करो आपको same answer मिलेगा. So we have done enough number of questions today. So tomorrow also we will meet at the same time and we do more number of questions definitely. Chalo, let's stop for today. I am giving you some questions as homework for you. Take a screenshot and give a try. Okay. All these are homeworks. Tomorrow I will discuss few of these questions and then I will move for network theorems. This question, all these things. ठीक है. So आपको मेरा ऑफिशियल टेलीग्राम चैनल चाहिए तो दिस इज माय ऑफिशियल टेलीग्राम चैनल शंकर 10. इसका लिंक चाहिए तो t.me शंकर 2023 is the telegram link. Right. So this is our IRMS team for with the batch is going to start on December 21st. You can see here you will get general studies and also this IRMS both together. So अभी आपको अनअकैडमी पे ऑफर भी मिल रहा है भाई, as you people know that there is a price drop offer. आप सब्सक्रिप्शन लेना चाहिए तो you can use my code and take the subscription. Thank you very much for your time. Okay, just a minute. So this is how you can take. Whenever you take the subscription, when you, your friend, anybody takes the subscription, don't forget use the code Shankar10 for getting maximum discount. Okay. So Unacademy पे AMT एग्जाम चल रहा है भाई. दिस इज अ वंडरफुल अपॉर्चुनिटी. डोंट मिस दिस अपॉर्चुनिटी. आप लोग अभी तक इस पे रजिस्टर नहीं हुआ तो कंपलसरी अभी रजिस्टर करो. लिंक अवेलेबल इन दिस वीडियो डिस्क्रिप्शन. इफ इट आस्क यू द कोड यू कैन यूज माय कोड एंड इमीडिएटली रजिस्टर फॉर इट. डोंट डिले इट फर्दर. Okay, because this all India level examination आप लोग हमेशा लिखना चाहिए so that you when you understand what is your position right now, how you are handling the exams. because आपको ये फ्री पे मिल रहा है ना, इसका वैल्यू पता नहीं आप लोगों को. बट इसके लिए ओरिजिनली इवन यू पे आल्सो यू डोंट गेट दिस. ऑल इंडिया लेवल कंपटीशन कहाँ पे मिलेगा एंड एग्जाम लाइक एक्सपीरियंस एंड पूरा गेट जैसा जो होता है ना कंप्लीटली ये सभी अब चीज आपको मिलने के लिए कंपलसरी यू शुड राइट दिस एग्जाम. सो रजिस्टर फॉर इट. 4 वीक बाकी है ना, सारे वीक पे please write this examination because you should compete with others. You should know your position. You should identify your mistakes, and you should also get habituated for the sitting for 3 hours and writing the exam, which can help you for your end exam. Okay, you trying your brain to do this. All the best. Thank you very much, guys. So आपको scholarship भी मिलेगा इस पे based on your ranking. So thank you very much for your time. See you all tomorrow at the same time. 4 बजे. Thank you. Thank you.